Okay, so here's section 3.1 where we're actually going to start doing some of the problems. So I'll just draw a line under our other work. Okay, this is section 3.1, number 8. I'll make that look like a title. I don't know. Okay, 8. Fill in the blanks and identify the property used. This is page 114 in your book. So they want us to talk about the property like the commutative and associative and distributive properties that all were on the very beginning of chapter 3. So if you need to look back at those, you can. Okay, so filling in the blank. Well, they took the 15 plus the 12, and then they made the 12 commute over to here, and the 15 commuted over to there. So I'm trying to give you a hint with my wording there. That would be the commutative property. So fill in the blank, though. They want to know what would go there. It's got to be the same thing. When you work it out, 15 plus 12 equals 27. This one's got to be the same thing. Well, yep, 12 plus 15 equals 27. It doesn't matter about the order with addition problems. So you're filling in the blank. You would have a 15 there, and then you would identify the property used, and that was, there's your blank, and then the property used was, what did I say? Commutative. My writing is a little sloppy. Okay, 9. I might just do this one here, and you can write it in your book while I talk about it. 3 times 2 minus 9 in parentheses equals what times 2 minus what times 9. So remember this, they've got to equal the same thing. So you can always check your work if you're unsure what to put there. But this property that you're seeing right here is the property that the 3, when it's sitting outside the parentheses, it goes to this one and it timeses to 2, and it goes to this one and it timeses against the 9, and then it gets spaced with whatever's right here. So there will, so this will be 3 times 2 minus 3 times 9. Let's work out both of these just to make sure that we feel confident. 3 times, let's do it on this side the way that it is, which you work out your parentheses first. 2 minus 9. If you've done some of your negative problems earlier, you'll know that the 9 is going to overpower the 2. You just need to know the difference between them is 7. We know that. But which sign is going to win? It's going to be the negative because it's all the way down in the negative 9s, and we only got positive 2 back. So that will be negative 7 in there. And that will be 3 out here. Okay, let's do this side a little. I work them all this way. I guess you could finish working this one out first. We could do that. That'll be negative because the negative wins. When you have a positive and a negative together, it ends up making a negative. And you may not have learned that yet, but it's coming in this chapter. So I'm going to go ahead and just show you what it works out to so that I can show you how the other side is going to come out to the same thing. 3 times 2 is 6 minus 9 times 3 is, I'm having a blank moment. Like really, let's see, 27. Yeah, okay. So 27. Woo! See, this would be a really kind of a long one to have to draw yourself out a number line. So hopefully you know that you take the difference of these two numbers. So pretend like you just needed to know what the difference. Remember that word difference means subtract. So just in your head think 27 take away 6. Well, 7 take away 6 is 1. So it'll be, you can do it over here. Minus 6, that's 1. So we know the 2 will just stay there, so it's 21. And which one wins out? Well, that negative 27. So now we have a statement of truth. Negative 21 equals the same thing, negative 21. So both sides are equal. We know we did that right. We filled in the blanks right. Now we just need to talk about what property did we use. What is the name of that word that they want? They want commutative, associative. Think about it. Flip back to your first page. You try to answer this before you see what I'm going to find. take me a second to flip back. Well, commutative is when they commute and they kind of switch where they're sitting. But associative is when they all have to be doing the same sign. They have to have the same operation. You can't have like some pluses and sometimes they all have to be plussed. They all have to be multiplied. You cannot do division or subtraction. So it's not associative. That's not what we just did because we worked out some of them in a different way. Let's see what the other one was. Distributive. Well, that makes sense because we distributed it. See how the 2 hit the 4? And, wait, okay, they did it this way. The 2 hit the 4 and got 2 times 4. You keep the thing that, you keep the plus or minus that's right there. So we put that there. And then the 2 hit the 3 right there. So it's multiplied 2 plus 4 plus, 2 times 4 plus 2 times 3. So that's 8 plus 6. Or if you had worked it out inside, it would have been 7 times 2. So that's 14, and that's 14. So it all works out. The same thing works for subtraction, except that sign right there. Make sure that your sign is what spaces them. It's got to be whatever that sign was. So our answer here is to fill in those blanks and call it the distributive. Let's just look at this one and see what's happening here. This one is, all they did was switch places. That's commutative. This one, let's see. Okay, we have a longer problem here. Parentheses. Okay, they're all using the same sign. That tells me something. That was called associative, I think. When they can all use the same sign, you can switch it up. Because that's just 2 plus 4 plus 8. And this is 2 plus. Okay, now they're associating with different ones, but it's all going to add to the same thing. That would be an 8 right there. So work out this side. That's 6 plus 8. And this side will be 12 plus 2. Well, is 6 plus 8 the same thing as 12? As 2 plus, if you want to keep it in order. As 2 plus 12, well, 2 plus 12 is 14. And 6 plus 8 is 14. So yes. So we know we did the math right. This thing in the blank is 8. And what we just did here was called the associative property. So like the 2 and the 4 are talking, they're associating, and they're leaving the 8 out. Or we can switch it up, and now the 2's left out, and the 4 and the 8 are talking. And the associative property. But you remember, they all have to be using the same sign. No mixing multiply with add. Or they're all being added, so that works for associative. Okay, this one looks like another associative. Yep, because look, they're all using the same sign. Okay, so 8 times 2, well, we work that out, and then it's times 3. Or the 2 and the 3 are associating. Which one is left out now? It would be the 8. So remember, your associative has always got to be using the same signs. If you look back at that page, that's just a really helpful keyword I'm noticing when it says it's for regrouping numbers only. The regrouping only occurs when the same operation is between all 3 numbers. It can't occur when operations are mixed like that. That's what I was saying. That wouldn't equal each other. You'd do the math and it'd be like 12 plus 2. And this is 5 times 4. That's 20, and that's 14. No, that would not work out. So anytime you're wondering, can this work out? You just do the math. So anyway, where was I? Oh, this was associative. Because they're reassociating. Okay, let's see what this one is. Okay, they give us a nice. It seems more complicated because it's bigger numbers, but it's really a lot like what we did here. See, they're together, except they're not telling us these numbers. But we should know because we've done this, sort of. Okay, so the 8 times the 2 and the 8 times the 77. That's what we can redistribute and leave this one to space them, which they left it. So already it's looking like a distributive problem. 8 times 2, so what did they leave for us? That would be 8 times 2. plus 8 times 77. Now, you can do this math right here. I would do it on my calculator. I mean, you're not necessarily going to have a calculator if you need to check your work, but like homework, just learning stuff at home, I wouldn't mind if you used a calculator for this. Although, now that I think about it, it may be good practice just with, sorry, I was already doing that. It may be good practice to just do the multiplication so that you get really fast with it, and then we'll stop doing it as much. Okay, so that would be 79 in here. So that's 8 times 79, and we're saying that's the same thing as 8 times 2, which is 16, plus 8 times 77, okay? Let's see what 8 times 77 is. 8 times 7 is 56. 8 times another 7. 56 plus 5, so that's 61. That's going to get confusing. Okay, 616. Whew. All right, 616 plus 16 is 6 and 6. I'm just going to do it right here. It's kind of weird writing while looking through the phone screen. Okay, 632. Okay, and then 8 times 79. And I know it's a little messy. I'm going to erase this out of this book. 8 times 9 is 72. Here we go. And then 8 times 7 is 50. Yeah, I just did that. 56 plus 7 is 63. Oh, wow. It's just fun when you see it work out because you know you're doing something right. If I can just write neatly enough. 632, 632. So we did that right. We distributed. So we used the distributive property. So you would write that out as the other part of your answer. So that's 3.1.